Hello, everybody. Welcome back to Fossil Friday Chats. It's been a minute. I'm Brittney Stoneburg. I'm at the Western Science Center, as you know. With me, as always, is Gabe Santos from the Alf Museum.
Happy New Year, everybody.
Yes, Happy New Year. We hope you all had a fun and safe holiday. And thanks for bringing us back into your Friday morning routines with Fossil Friday Chats. It's been a little while since we did this, but we are excited to get back into it and teach you all about paleontologists and the stories they have. And joining us today with her story is our friend Amy Atwater. How you doing, Amy?
Yay!
I'm so good. Hi, thank you for having me and putting up with my technical difficulties.
It's the start of the new year. It's fine. We're all still trying to get back into the swing of things.
Yeah, no big deal.
Yeah, we worked it out. Y'all are the best.
I mean, like, not gonna lie, like, I came on like an hour before all of you guys did because I had to set up my whole computer again because, like, I had not used Fossil Friday Chats and I've only been gaming all winter break, so everything was all out of place, so don't worry.
Yeah, I sat here, I was like, all right, I say my name, I say where I'm from, I say what we're doing here, introduce the guest. I had to remember, like, how do I do a Fossil Friday chat? So it's definitely getting back into the swing of things for all of us. So we're very excited to have Amy Atwater on the show. She's been a friend of ours for a very long time, and we've been wanting to have her on the show for a while because she is very cool. Amy is a vertebrate paleontologist who studies Cenozoic mammal evolution. So she's the objectively correct paleontologist who has decided that mammals are cooler than dinosaurs.
It's true, they are.
Very true.
She has a master's from University of Texas at Austin and a BS from the University of Oregon. So yeah, like I said, we're very excited to have Amy. She's also has an amazing Instagram. If you've ever followed her social media, she shares amazing things. She's incredibly knowledgeable.
One of my top psychomers, if you ask me. So.
Oh, thank you. That's very nice of y'all.
I'm excited to see your talk today because it's about primates, and most of us know that Brittney doesn't like primates, so it's gonna be great.
I am okay with some primates. Lemurs are wonderful primates. Monkeys, yeah, I mentioned off screen when we were setting up that I was glad that my camera would be off for the duration of the talk because nobody would have to see me squirm.
Yeah, we do have a few monkeys, but not too bad. Not too many on the monkey front today. So mostly cute lemurs and tarsiers.
Oh, thank goodness.
Yes. I mean, you're talking about California primates, and that was part of my master's thesis, so I'm really excited to learn more about these guys. Because I only looked at 2 for my thesis, and I only included 1 in the thesis, so...
Yeah, and I think yours are technically a little bit younger than the ones I'm talking about here. When I was like, the last primates, I was like, no, I think technically the Sesame ones are a little, oh, well, it's all close enough.
Yeah,
last-ish.
Yeah,
they were like barely there anyway. They were just like little things that were hanging on.
Yeah. So, as always, if you guys have any questions for Amy, go ahead and put those in the chat. We will have a Q&A session afterwards, and we'll try to get to as many questions as we can in the time allotted. So, Amy, whenever you are ready, go ahead and tell us about the last primates of California.
All right. Well, thank you both so much for having me and helping me out. So, Gabe is going to have to help me out with changing my actual slides because my computer is as ancient as the fossils I'm talking about. So we're going to be talking about the last primates of California today. So this is some work that I did when I was didn't do a PhD, when I was a graduate student. And so this is an image that shows the 3 new genera and the 3 new species that I named from the Friars Formation of San Diego. So we can jump on in. So this, just to give some context of where I'm coming from today, I'm actually coming from Atlanta, Georgia, of all places. However, just last week I was in Eastern Oregon at the John Day Fossil Beds National Monument. This is a picture of Sheep Rock there, and on the left you can see me as a 5-year-old with my brother at Sheep Rock, and here you can see me just this last August at Sheep Rock, where I was a museum technician for a season. So I was working out in the John Day fossil beds, looking for fossils, preparing fossils, and cataloging fossils. And my whole history starts at the John Day fossil beds. I grew up in Eugene, Oregon, and going out to Eastern Oregon was the place to go. And I got to grow up with just incredible fossils. And I think the next slide shows some of those. Yeah, so this is a mural of the Clarno Formation at the John Day fossil bed. So the Clarno was deposited about 40 to 44 million years ago. I like to talk about Oregon fossils because they're so strange and foreign to the animals we have in Oregon today. We had things like brontotheres seen on the right there in the front on the left side of the screen there. We have ancient horses from this time period, and we also have all sorts of things like camels and rhinos, and when we get to younger things, we get saber-toothed cats and false saber-toothed cats and Terminator pigs with terrifying teeth because they're like a mixture of a pig and a hippo, and thunder beasts again, and all of these really, really cool mammal fossils that just inspired me while I was growing up. And I never really went through a dinosaur phase because I had all these cool ancient fossil mammals to work with and be amazed by. And one of those fossils in particular is, if we can go to the next slide, is this really strange creature called Egimoishashala. So Egimo, which we call him for short, was a type of primate that we had in Eastern Oregon, and it had really weird teeth. So on the right-hand side of the screen, you can see some of their lower molars. And then on the left side, you can see a reconstruction of 2 of these Egimoishashalas. And they would have been, it's kind of debated if they would have been early lemurs or an early tarsier-like primate. However, they were very strange. They were weird. And another weird fact about them, besides being very rare and only a handful of their teeth have even been discovered, they're also much younger than all the other fossil primates that we have in North America. And I'll go into that a little bit later. But just remember that Egimo is a weird one that really inspired me from a young age. And the next slide, I think, goes into, yeah, I did my undergrad at the University of Oregon, where I got to work in the John Day fossil beds there too. And I did an undergraduate project on omomyids, which led to a graduate program at the University of Texas at Austin, where I was in the Department of Anthropology, and I studied extinct primates, and I was a National Science Foundation Graduate Research Fellow. So if we have any folks who are pursuing careers in paleontology and students, if you're looking at graduate schools, a really great funding opportunity is the NSF GRFP. So I highly recommend looking into something like that. And yes, so I got to study all sorts of really fascinating primates at UT Austin. And I think we can go to the next slide. And that kind of gets us into, before I dive just into the new species that I got to name and describe, I kind of wanted to go over a few of the basics. And I'm so sorry, Brittney, for this slide of pictures of apes and monkeys. Sorry. But what is a primate? So if we look at this here, this image here, we see 4 primates. They are all primates, even though some of them are monkeys, one's a lemur, some of them are apes. So what exactly is a primate? We are primates. How is our family tree defined? Next. So one of the things that we look at, and I'm going to talk a lot about morphology. As paleontologists, we have to look at what the bones look like to be able to interpret fossil things that don't have any fleshy bits left on them. So the adaptations I'm going to be talking about are all morphological things that we look at in the fossil record to interpret if say a fossil is a primate or not. So one of the things we looked at is adaptations for improved vision. Oh, vision is didn't make it on that slide. That's okay, that would be the word there. But you can see these are a bunch of forward-facing eyes. So that's one of the major things that we see in all primates today are forward-facing eyes. So forward-facing eyes are going to be things that allow us to have binocular vision. We have overlapping range of vision, which allows us to have great depth perception and grasp things with our hands really, really well. We share this with some other animals like cats or owls. They also have forward-facing eyes, and it's thought that we have all evolved these adaptations because we're grasping things with hands or feet, and we need to have that good depth perception. So all primates are going to have forward-facing eyes. And the next one is about adaptations for grasping, for hand and foot grasping. So here we have a little lemur and a monkey that are kind of demonstrating the incredible adaptations that primates have for climbing. A life in the trees is definitely a pretty important part of primate evolution, though it's not necessary. Not all primates live in the trees. A lot of primates are terrestrial. Think of baboons or something like that. So we have these really cool opposable thumbs and hands that are great at grasping. Humans are weird because we don't actually have an opposable big toe anymore, like this monkey has. So most primates do have an opposable big toe. We actually decided to do away with that so that we would have better support for being bipedal, walking around on two legs. So to be able to stand up better, we needed to have better foot support. So we lost that opposable big toe. And our next one that for adaptation is going to be about, I think, hearing. If we can go to the, yep. So the auditory bulla, the inner ear, is composed of, for primates, the petrosal bone. Again, this is like really nitpicky morphological terminology, and I want to highlight it because we do debate a lot in paleontology whether or not a fossil is a true primate or not, and features like what the inner ear bone and the outer ear bone are made up of is really important, it turns out. So all primates have the ear bone, the auditory bulla, that is composed of the petrosal, like the skull on the left there. On the right is a cat skull, and I'm pretty sure that their inner ear is the ectotympanic, I believe. So different animals use different bones for those ears. What I'm not going to actually talk about, that is a common misconception, is that all primates have big heads or bigger brains. And while monkeys, apes, and humans definitely do have those features, it is not shared throughout all primates, and I don't feature it because of that. Some lemurs have a brain size that's very on par with other mammals of their size. So that's why I don't actually talk about increased brain size for all primate adaptations. All right, and the next one. And then we also have, oops, forgot about this one. An important one is going to be nails versus claws. So if you look at your own hands, we have these beautiful nails. My mom painted mine over Christmas. It was very nice of her. Instead of having like a claw that you might see on your cat or your dog. Now, some primates, including lemurs, are going to still have a grooming claw, and that's just on one digit on their hands and feet, and it's also called a toilet claw, and it is for grooming purposes. And so we do still see some claws, but only in early types of primates like lemurs. And then again, this is very debated. If you heard of Darwinius, a really famous fossil primate, a lot of times folks were calling Darwinius the missing link. As if it was on the line to humans. It had a grooming claw, and it had other features of lemurs, and it is actually more likely that Darwinius is a early lemur than it is on the line to humans. So these little things like whether or not you have a nail or a claw at the end of your hand or feet actually matters a lot to paleontologists trying to figure out what these animals were doing in the past. All right, next. Okay, so this is just a little tree that kind of shows you Euarchonta, which is our group of our little family tree, if you will. So primates are going to be all of the ones seen in the red. So lemurs and lorises, tarsiers, monkeys, and apes. And us, we are apes. Our closest living relatives are tree shrews and flying lemurs. Flying lemurs are also known as colugos. They're really cute. They have like the extra skin wings and they can kind of wrap themselves into their own skin hammock sometimes. And it's like the cutest thing I've ever seen. Highly recommend Googling colugo. Highly recommend it. So those are kind of how we define what a primate is in the fossil record. And those are going to keep in mind, however, all of the fossils I'm going to show you are just of isolated teeth, because in the fossil record, teeth are much more likely to preserve than others. So let's see what the next slide is, because I don't remember. Okay, so in North America, primates arrived around 56 million years ago. This is after the Paleocene. So dinosaurs have been extinct for about, well, non-avian dinosaurs have been extinct for about 10 million years. And it's at this time period that the climate gets really, really hot across the whole world. It's called the PETM. It's the Paleocene-Eocene Thermal Maximum. And it allows like tropical conditions to exist at the poles. We even find primate fossils at the poles from this time period because even the coldest places today would have been hospitable for primates during this hothouse Earth time period. So that's when we really see primates making the scene here in North America is right around 56 million years ago. And we can go on to the next. I personally study omomiids. So omomiids are going to be, this is a reconstruction of one called Shoshonius, and this one is on the line to tarsiers here. So omomiids are what we would call an early tarsier or an early haplorhine. So tarsiers, monkeys, and apes, we're all haplorhines, which just means we have a dry nose. Lemurs and lorises are called strepsirrhines because they have a little wet nose, and that's what that means. So omomiids, as you'll see in the next slide, are really, really, really small. All right, so that's my finger. It's like literally my fingerprint. And this is the majority of an upper jaw from a primate called Diablomomys dalquesti. So this is an omomiid from West Texas that I got to work on for a little bit during my master's. So that's the upper third premolar, upper fourth premolar, and then we've got the molar teeth there as well. And that fits very easily within my fingerprint. So they are very, very, very small. Omomiids, very small. And you'll see one of the biggest ones is one that I described a little bit later, and you'll see that it is tiny as well. So we can go to the next. All right, so we talked about 56 million years ago, primates get to North America. Here is an image of North America about 50 million years ago. This is a Ron Blanke reconstruction. So you will notice that while some things look familiar with North America, there are subtle differences as our landscape has evolved over time, especially with the coasts. And you can also see it's very green, lush. A lot of the North Pole is all still connected. And that yellow star indicates where most omomiid fossils are found in North America, which is in basins within the Rocky Mountains. And I don't mean like necessarily at high elevations, though sometimes we do find them at high elevations. I mostly mean in the lower basins in between these big mountain thrusted events, essentially. And so places like Wyoming, that's where the star is, are just hotbeds for omomiids. We have found the majority of the omomiid material in North America from that general area of that star. And in the next slide, you can see two other stars. So we have a star that's kind of over Texas. This is where we've also found omomiids before. So West Texas, like that Diablomomys I just showed you an image of. And then that other star on the coast, the Pacific coast there, represents Southern California. You might be thinking, gee, Amy, that looks a little too far south for Southern California. And you're correct. And that is because the rocks that were deposited 50 million years ago would have been further south than their current location because of plate tectonics and the shifting plates, especially along that west coast. So the omomiids living in these southern spots of Texas and California would have actually been closer together 50 million years ago than they are today, because not only do animals evolve, but so do our landscapes. And it's really important as paleontologists to keep in mind all of the geologic activity that's going on and how that could impact your organism as well. So we can go on to our next slide. I have been curious about studying the differences between these colder northern locality omomiids, represented by little Shoshonius in a hat and some gloves, no, just a scarf, versus these southern localities of omomiids, which is represented by Shoshonius in a little bikini and some sunglasses. So that's what really inspired my master's research, was trying to understand if these are all the same types of primates that are living even from the north and the south. What kind of differences do we see? Are there morphological changes, or are there temporal changes? Does it change depending what time it is? So that's really what inspired me to continue with my research. So that led me to my next slide. which was a project in 2015 looking at variation in one specific type of omomiid called Omomys carteri. So Omomys carteri is thought to have been this very cosmopolitan omomiid. It really got around. It's found all over the place, and it persists for a really long time too, a little longer than you would think for a fossil species could persist over, like, I think it's over 6 or 7 million years. So I got really curious about, well, is this truly actually Omomys carteri, or have we had enough variation at this point where it's a new species? And I did an entire project and poster at SVP where I was looking at the amount of variation in Omomys carteri, specifically between the West Texas stuff and the northern stuff from Wyoming. And in the next slide, you can see that it was at this conference where I got to meet Gabe for the first time. Yay! And I definitely fangirled really hard. Yay. Okay. At that conference, I learned that there were Omomys carteri at the San Diego Natural History Museum. So I decided to take a trip to the San Diego Natural History Museum to look at all of their stuff. If we go to the next slide, I decided to look at everything labeled Omomys or Omomyidae at that family level, to try and determine if these are truly Omomys carteri or are they something new. And if you go to the next slide, yay! I quickly realized that these fossils were not Omomys carteri. They were something new. In fact, they represented a bunch of new genera and a bunch of new species. And that was probably my facial expression the majority of my time working on these, because they're really cute and it was very, very fun. So it was there I realized that we had new primates and new omomiids. We can go next. Yep, so these ones are all of these primates are from Southern California, from San Diego. They're actually from the Friars Formation specifically, which is highlighted in red. That is a transgress regressive kind of unit. So we see some shoreline activity with some marine rocks nearby, but also fully fluvial systems as well. It isn't a very well understood unit in terms of, well, that's not true. It's been very well studied. However, some of the problems with Southern California is that it's so well vegetated, it can be really hard to see your rocks. And also, there's so much construction, it can be really hard to understand what's going on too. That can also be a secret weapon for paleontologists as well. So we can go on to the next one. So my 3, which I didn't label them, I guess I ran out of time. My 3 new species, and I should say they're 3 new genera. So genera is just the plural of genus. It is a weird pet peeve of mine when people say genuses. It's okay though. How else do we learn things? So I not only described new species, but I also described 3 new genera as well. So I might just refer to them as new species because it rolls off the tongue a little easier. So this shows that the 3 new groups, the 3 new taxa, were really great in that they were all in their own size range. They never overlapped within their size range, which was even more evidence, not only morphological, but also size-wise, that they were their own unique individual species and genus in this case too. So we're going to start with the smallest one and just quickly go through small, medium, and large and just show you what some of those look like. They're all teeth. So we'll go on to that next one. So this is the smallest one. This is Equiamachus walshi. It was based on 32 isolated teeth. They were all isolated. I didn't even have any jaw fragments or anything. So when people are like, you can't name a whole species after isolated teeth, and I go, well, I did, and it was accepted and peer reviewed. So it is a valid new genus. A lot of times when you're dealing with stuff as rare as primates, all you have are teeth, and you have to work with what you got. So things that made Equiamachus unique is its small size. It also kind of has this wasting in the middle of those upper molars on the upper part there, where it looks like they've kind of been cinched in a little bit. And they've got some interesting valleys and grooves in their teeth as well. Equiamachus is a name by the Cuyama people who lived in and live in the San Diego region. It means the place beyond the clouds. And walshi is named after Stephen Walsh, who actually found all of these fossils that will be talking about. And he used to work at the San Diego Natural History Museum as a paleontologist. So Equiamachus, on the next slide, we can get you an idea of the size. So there's an artist reconstruction on the left of Equiamachius, and it has been compared to the size of a modern bush baby, or a galago, if you will. So a very, very, very small, very, very cute primate. Probably would have looked fairly similar to to this cutie patootie on the screen. So that's the smallest. That's Equiamachius. Our next one is Gunneltarsius randalli. And so this was our medium-sized guy. It has a lot in common with Omomys carteri. However, it did have distinctive differences that made a new genus valid. So here I did have a few more segments of jaws, either upper and lower. And I did have a larger sample size on this one too. So Gunneltarsius randalli, that name comes from Greg Gunnell. It's named after Greg Gunnell, who was an incredible paleoanthropologist, paleoprimatologist, who passed away right around the time I was working on this project. And he helped me many, many times, and it was just a really great guy. We wanted to show our respects to him. And then randalli comes from Kessler Randall, who is the collections manager at the San Diego Natural History Museum, who helped me immensely with this project, put hours and hours and hours of work into it. And I wanted to show the respect I have for all of his time. I also then became a collections manager later, and I'm still waiting for someone I helped to name an entire species after me, but we'll see if that ever comes back my way. Let's go ahead to the next slide to see an idea of Gunneltarsius. Would have been similar in size to a fat-tailed dwarf lemur. Don't you just love the names of lemurs? There's some really clever ones out there. So a little bit bigger than our bush baby, but still by no means large. I mean, you can see that these are still very small primates that we're talking about with Gunneltarsius. So that's Gunneltarsius. And our last new one is Brontomomys cerudi. So Brontomomys was a sample of about 39 specimens. This included some of my nicest jaw fragments. And man, Brontomomys is the largest, not only of the new taxa, but also for all Omomyids. It rivals the largest sizes of Urea, which is another really big one, or Macrotarsius, another large one. So that's why I decided to name it Brontomomys. That means thunder shoulder mouse, to show the big size of this little guy. And cerudi is after another researcher who also was at the Natural History Museum and who also found a lot of my specimens that I got to work on, and I'm just very grateful for his work as well. So let's take a look at what Brontomomys has been reconstructed as. So again, I say Brontomomys is the largest, and again, that lower left image shows you the largest specimen I have of it, a lower jaw, in my hands. So again, it's not even the length of a finger, it's only the length of like one digit, one part of my digit. Above that, you can see an artist reconstruction, and then on the right, you can see it's been compared to the same size as the sportive lemur. That is, again, a little bit bigger than those fat-tailed dwarf lemurs, but still smaller than, say, a ring-tailed lemur or one of the larger ones that you might see too. And that's Brontomomys cerudi. So those are the three new specimens and the three new genera and the three new species. You can go on to the next slide. These really matter, not only because they're new to science and they've been waiting under our feet for a really long time, but also because at this point they're only known from the Friars Formation of San Diego. And here's where I also want to just do another little plug for Stephen Walsh and his incredible work. He's passed away. However, as I said, much of Southern California is completely, I mean, it's been built up. I mean, there are construction projects all the time. So most of these fossils came from localities when these buildings were construction projects. And Stephen Walsh was bright. He was just so talented and brilliant that he knew where these construction projects were and where in the stratigraphy they were. So he could go to, say, the Miramax Tunnel. I remember that being one of my locality labels. And sample and know generally where in the strat column he was, and then go sample from another building site and have a good idea of, well, how the heck do all these rocks relate to each other? Because again, so much vegetation and so much building, it can be really hard to connect these rocks. And so the fact that he spent so long working on isolating these fossils is really impressive. And we see that they are only been found so far in Southern California. Now, this may be because we just haven't found them other places yet, Or it could be that they really did not exist other places and they truly were well adapted to their environment in Southern California. And we can go on to the next slide here, which is just kind of talking about a big part that why I care so much is about conservation. So today, almost every single primate is threatened by extinction, if not on the verge of extinction. And here I have just told you about this fossil record that we have here in North America of primates going extinct. And we can use that as a control. We can use that as a way to study and understand what factors led to those extinction conditions in the Eocene or in the Oligocene, and how could we use those factors to better protect primates facing extinction today. And this is kind of a new field in paleontology, paleoconservation biology, and I really encourage folks out there to be thinking about ways that you could include in your research ways that how will your studies impact primates alive today. And we can see that that primate populations can be very localized, that they can be very cosmopolitan, and how can we use that to maybe focus efforts both on a local basis and more on a global basis for protecting these primate species. So I want to thank y'all so much for having me. I hope I didn't speed through that way too fast. I have some more, hopefully we'll have some time for questions as well. And thanks for that quick rush down San Diego's primitive past.
That was awesome. What is it about that lemurs that always make them look like you scared them when you take their photo or when you like reconstruct them?
I think a lot of times it's because they have such beautiful colored eyes that they really contrast against their dark fur a lot. And so like it's like this brown and then like piercing green eyes. And you're like, well, they do. And I should have said this. I try to say this a lot. Tarsiers you've probably all seen tarsiers because they use them in ads for being over caffeinated all the time. They're just like.
That's what I look like after I drink coffee.
Yeah.
I think one thing that I really loved about your research that you kind of like I looked a little bit when I was doing my master's thesis was like the way that the endemic faunas in California were really different from the things that were happening on the interior of the United States. And in my head, I was like, everything on California side was just living the dream life right along the ocean. It was great. They didn't have to do much. It was awesome for them.
Yeah, I think that too. That's why I made that image years ago of just like the cold Omamiad versus the like cruising down the Pacific Coast Highway Omamiad.
Like, this is great. Yeah. I also loved the bit where you're like, oh, you can definitely name a species over some teeth. And I was like, the horses also agree. Thank you.
You work with what you got.
Yeah, you work with what you got. And a lot of times what you've got is teeth.
It's teeth. Yeah.
Yeah, so we've got some great questions, and we have plenty of time, everybody. So if you have other questions, feel free to go ahead and put them in the chat. Our first question is from Charlie. Does diet or dentition affect the primates like classification, how we classify these animals?
That is a absolutely great question. So diet, not necessarily. Of course, diet is going to influence your morphology. Because it's a great question to go, you're looking at isolated teeth. How do you know that these are even Omamiad teeth, right? Versus an adapid teeth, which are like the lemur-like ones, like Darwinius. And so you are just looking at morphology. We don't necessarily know if all of the features that we key on for ancestry are also informative for like morphology, if that makes sense. You know, we can tell Omamiad teeth are Omamiad teeth because they all kind of look like Omamiad teeth because they all evolved from an Omamiad ancestor. And same with adapids, like adapids have that situation too. Now there's going to be variation in that because of what you're eating, and you might have an Omamiad that looks a lot like an adapid, but hopefully there's still some residual holdovers from that ancestry that will give you the idea that it actually belongs with the Omamiads. But, you know, we don't know. I have no idea what these animals actually looked like. I would love to time travel back to the UN, but we'll see about that.
Awesome. Another great question from Charlie is, can we tell if fossil primates had prehensile tails?
I bet I know who this Charlie is too. Hi, Charlie. Thanks for watching and supporting me. I appreciate it. That's a great question. We can tell if an animal has a prehensile tail from morphology. You have to look at those caudal vertebrae. So those are going to be your tail vertebrae. And if you look at those, if we look at the modern primates that have, or modern animals, it's not just primates that have prehensile tails, you do see pretty characteristic traits in those processes off of those vertebrae that are for extra muscle attachment that are allowing for them to have a better the grip. So yes, I do think you can pick up on that osteologically. Now, whether or not you ever get enough of a tail preserved in the fossil record to actually say, but I mean, I'd be curious if the folks working on Darwinius looked at the tail, because it did have a beautiful tail in that one, though. Yeah, no lemurs I can think of have prehensile tails, so that'd be interesting.
Be cool. Alrighty, let's see. This is from Bill, who says, I live in San Diego. Are there any paleontological sites that I can visit in Southern California? And Gabe could probably help with this too.
I was going to say, I think you guys might be more on trend. Tell me, and I'd like to come, because I've honestly never seen the Friars Formation in person. I've only ever seen it on papers and imagery. But I do know that Southern California is just teeming with incredible paleo localities, and I would, listen to the experts on where to go.
There are a lot of great places you can see the rocks. And like, if you go down to even the beach, right, and you look at the cliff sides down by La Jolla, I think it is, you can actually see some of the formations where the same formations where fossils have been found. The thing is, if you're looking for specific fossil sites in Southern California, you're not going to find a lot of them, because especially down along the coast, a lot of them now are parking lots or housing developments or Targets or Starbucks and things like that. So because like Amy had said in her presentation, a lot of the fossils that were found in San Diego, which I looked at as well for my thesis, you can't go back to those sites because we found a lot of them through paleontological mitigation. So California is really special because we were the first state to have laws that said that whenever you do construction of a freeway, of a shopping mall, whatever, you have to have a paleontologist, an archaeologist, or a biologist on site. And if you come across fossils, they have to halt construction, they have to collect those fossils out, or as much as they can, and bring them to a repository, like the San Diego Museum, the Natural History Museum, Brittney's museum, my museum. And so that's how we have so many great fossils here in Southern California at all these repositories, because we're constantly building and we're always finding them. Most of my fossils, I think, came from a freeway reconstruction. So the other thing, too, I want to say is, like, if you go and look at some of these fossil sites, Southern California, like I said, we have very specific laws when it comes to fossil collection. So it's always best in anywhere you go to leave fossils where they are. In some places, it's okay to collect plant and invertebrate fossils. But it's always best to just leave it where you are, double check the laws. And if you find something, email like a park ranger, go to the park ranger station, email a museum. They can help you figure out where it's okay to collect, if it's okay to collect some things. But the best rule of thumb is if you see vertebrate specimens, just leave them alone for now.
If you want to be really adventurous, mark it on a GPS and tell your park ranger or tell someone like that, and then they can find it and go from there. But yeah, leave it where you found it.
Like really quick too, it's not just because we don't want people to enjoy fossils. We want everyone to see where these fossils come from. But the thing is most of these fossils are important data points for a lot of paleontologists. Like for Amy, right? If she wasn't able to see all of those different types of Omamaya teeth, the different specimens, she would have had not a great sample to compare others to. So that's why we want to preserve as many of these specimens as we can for research. And if they're preserved and kept in a museum, they are more useful for research down the line. And also we can bring them out for outreach and education. And so everyone can enjoy them from our institutions, and we can put them online, do Fossil Friday chats like this. And researchers can come and create describe new species like Amy did.
Exactly.
I do want to thank you for having this entire platform for that exact reason. Those fossils had not been looked at in over 20 years when I went to the San Diego Natural History Museum. And this is a great way. It's boring research stuff, sure. And then hopefully because of opportunities like this, those fossils that would have just sat there, now more folks who are even, from the communities, that's who this you should really know about. That's under your feet. So I do think that opportunities like this is great because they just sit, they can just sit there for a long time. So.
Well, I mean, that's cool to say because we have a teacher in the chat who said, where was it?
Let's see. I teach I teach anthro in San Diego, and my students are amazed that other primates used to live here.
Yeah. That's so cool. And it is strange. I also had to, sometimes folks are like, oh, Egimo is the last. Anyway, we're going, that doesn't matter. But primates are cool. Primates are cool.
Even I will admit this. All right. This is from Christopher. Are there any other fossil remnants in those San Diego area collections other than teeth? Do you find any postcranial?
Oh, yeah. And again, so I came in with tunnel vision. I already had my project in mind. I already knew what groups I was looking at as I went in and looked at Omamaidae, essentially. Of course, there was other material there. And there was some long bone. There were some bone material associated with Omamaids, but since you can't ever tell what tooth goes with what, it's really hard to do anything with postcrania. And then again, I think Gabe had a chance to work on a lot more of you were doing more looking at, if I can recall, what was going on in those ecosystems, whereas I was really only keying into just primates.
Yeah, I was looking at a bone bed specifically from right between Orange County and Southern California and San Diego. And so this bone bed had tons of different Eocene mammals from the Sespe and Santiago Formation. And so I was looking at and so I went to San Diego just like Amy did, but I was pulling open all of the drawers. So also thank you, shout out to Kessler Randall for bearing with me for a few days while I pulled open all the drawers and messed with this collection. But yeah, there were tons of Eocene fossils there. And the Eocene actually, they're cool in the San Diego collection because they have their own special room just for them.
As it should be.
Exactly.
Okay, I like this from Charlie. This is just a comment, not a question, but this is hilarious. You should Photoshop an Omamaid onto your shoulder like a parrot in your next presentation.
I like that. This goes back to Joseph Leedy is the one who named Omomis Carteri back in the day. He has a great history of naming things, and he named Omomis, literally translates to shoulder mouse, because he thought it looked like a little mouse that would fit on your shoulder. And that's so it is pretty cute. So Brontomomies is thunder shoulder mouse. Yeah, so that's a great idea, Charlie. I will work on that. It'll be next to me writing the Brontothir.
That is so cute. This question is from Ed. He says, Hi,
Ed.
Oh, hey, Ed.
Why do North American primates seem to get hit so hard with extinction? Are they dramatically affected elsewhere in the Eocene?
That's a really great question in terms of other, I only think about North America. This is why you should always collaborate, kids. Not just be stuck on your one time period. I think it's pretty well, there's a lot of good evidence that climate is playing a huge role in this. I mean, I talked about the PETM. We go on to have the mid-Eocene climatic optimum, and you have a few more little pulses of heat there through the Eocene, but then, man, you hit the Oligocene and things, as Ed knows, things really cool down, and we see quite a bit of turnover across mammalian communities, all of them, and it's largely tied, I would think, to that cooling climate and the loss of that habitat for those primates. And that is something we see in modern primate habitats today, is that loss of habitat is a really fast way to really hurt those numbers. So we're doing it by cutting down their habitat, whereas the Oligocene was doing it by cooling down the habitat. So I think it's just different.
Amy, I don't know if you came across this when you were doing your research, but somebody had told me this idea that Southern California, when we're looking at the extinction of stuff from the Eocene, they kind of things in California lasted like a little bit longer than the rest of the United States. And so they're saying that California might have been this refugia of like this nice paradise, while the rest of the United States were going through these dramatic changes. California was going through it just a little bit slower, and so things were able to last a little bit longer here. Is that something you saw or heard of when you were doing your research?
Yeah, and the term refugio, yeah, like quite a bit, and especially because my master's advisor, Chris Kirk, he is the one who works on those West Texas populations, and same stuff in West Texas. We're seeing weird holdovers. We're seeing these in other animal groups too, not just the omomyids and primates. We're seeing it with some of the artiodactyls. We see it with some of the reptiles. That things, and it makes sense, doesn't it? I mean, it's further south. Like there is going to be a difference in climate. This is why I love studying North American land mammal ages. And, people try to tie direct dates down to a land mammal age. And it's like, no, slap that out of your hand. That is not what those are supposed to be used for, because it's, because it's going to be times transgressive. It's going to change where you are because everything can't be held constant. And what I'd really love to see is more interdisciplinary work and what is the word I'm looking for? I need to work with Mexican paleontologists, because we're talking about San Diego and West Texas. Well, what's in between there? Okay, Mexico. Like there are definitely homomyids from these areas. There's really cool Eocene rocks. I think it would be awesome to be able to collaborate more internationally, and be able to see. I think what we're talking about in California and West Texas is probably being seen in a lot of parts of Mexico as well. And I'd love to study that.
No, that's a great point to bring up too. It's like these boundaries that we have today they're fake, right? They don't really exist. And so millions of years ago, these things were moving about. There were no borders telling where these ancient animals to go and live. And so if we want to look at the fossil record and understand things, we have to be able to look at them without borders.
Yes. Yeah. And like even some geographic barriers like the Rio Grande River, okay, I don't even think that was there 50 million years ago either. So, when I'm standing in Big Bend National Park and can see Mexico, I don't ever get to go there. And it's very, I think that there's a lot of room for that, hopefully down the road, especially because that is some of the broader significance of this research is what's going on at these southern localities and why are we seeing differences, and is it as simple as climate? Is it as simple as latitude? That kind of thing.
Awesome. I think this is a great question that I think we can end on. And again, this is from Charlie. And this is a question for all three of us. What advice would you give someone who wants to get into paleontology, but lives in a country where there's almost no paleo? New Zealand, for example, is very geologically young.
Could I start with that one?
Yes, go for it, Gabe.
Okay, Charlie, we'll get to your question for advice for paleo, but New Zealand has great paleontology. New Zealand has amazing marine mammal paleontology. Some of the coolest whales and other marine species have been described from New Zealand. And, not just that, but there are some other really cool animals that have been found there in Aotearoa. As, there's so many cool things. Just if you go online and look up the University of Dunedin, I think it is, that's where they do some really cool marine mammal paleontology. And you will find some really, really cool stuff. And so there is definitely paleo going on in New Zealand. And also New Zealand is actually a remnant of a continent called Zealandia.
It's like the Southern Alps, right?
Yeah. And so like there are some really cool, like even older, like I think Jurassic, something like that, rocks down there that are like limestones. And I know it's not mammals, but there are cool stuff out there. It's not very widely popularized, so that's not your fault for not knowing. You just gotta have somebody tell you these things, and we're telling you now. So you'll find some cool stuff.
We'll be those people.
Now, as for the advice, we'll leave that to our guests. I'm done with my rant.
I think Charlie and I have had some conversations about this actually, and that's, I think you have to make the best of where you are. I don't necessarily think of like Georgia as like, wow, fossils, but there are fossils here. and they're incredible paleontologists here. And I've had to work to network with them and get to know them. But they are here. Texas was the same way. I went to Texas and I was like, oh God, what am I gonna, and it was just like talking to locals. What are your local opportunities? Like, I don't actually really care too much about the Western Interior Seaway, but I was in Texas. So you go look for dinosaur tracks in the Western Interior Seaway. It's just like what you do. So you kind of have to make the best of the opportunities wherever they are. And I bet you'll then come away maybe like, I never thought about, oh, Oregon, oh, how limited, there's no dinosaurs. I never thought about it like that. It was always awesome and so much. So you got to find a way to make those aspects and then become an expert on those aspects of New Zealand. And I think, is it Bobby Bosnecker who did a postdoc at Dunedin? You should hit up Bobby Bosnecker, who runs the Charleston Museum, CC something.
Mace
College of Charleston.
Mace Brown.
Mace Brown.
Their Instagram is fire.
It's great.
Yep.
And he would be a great contact for you, Charlie, of someone who is active in paleontology and who knows your stuff and is just really cool, does really cool research. So I'd be a person to reach out to.
Yeah. And I like what you were saying about how you have to kind of work with what is around you. Like, Gabe was mentioning all of his work here in Southern California because he's in Southern California. I study horses because that's what I found in Southern California. Mm-hmm. There's something to be said for looking around you and be like, okay, well, it's not these dinosaurs, but that's okay. Dinosaurs aren't even the coolest, Tiny horses and primates and whatnot, those are the coolest. But, so figuring out what's around you and where the gaps are in the research.
Yeah, that's well said. Yeah, you'll be great, Charlie. You've been networking for years now. You're going to be great.
All right. Well, I think that does it for questions, Britt.
Let's see. There is one more if we've got time.
All right. Yeah.
Okay. This is from Eugene. Said, hi, Amy. Great program. I used to do underwater research in La Jolla while at UCSD and wonder if there are also underwater dig sites. Also says, we love and miss you here in Eugene.
Oh, that's wonderful. Oh, that's great. I've always wanted to do an underwater dig. I don't do them. I'm sure there are opportunities for that. I know that there have been options in Madagascar. They've had to do a diving there for lemurs and crocodiles and cool things like that. And then our friend, another SciCommer, Ben, whose name
had him on the show.
Okay. He does underwater. I remember talking to him at a conference and being like, but how do you take a GPS coordinate for it? And him being like, we have our ways. And me being like, how? So that's a cool person to, if you're interested in following someone who is actively diving in Australia and finding really cool fossils and just has so much positive energy and just really, really cool stuff.
Ben and James were previously on Fossil Friday Chat. So if you'd like to learn more about that, we definitely have that video.
Yeah.
Yeah. Ben Franciselli.
Cool. There you go. I love
it. All right. Well, I guess that does it for today's episode. Thank you so much, Amy, for joining us and sharing this really cool story of the last primates of California and freaking out Brittney for a few slides. It was really, really wonderful to have you on the show today.
Thank you.
If folks want to learn more about your research or just, learn more about you, where's the best place for them to go?
The best place for them to go is Instagram. You can find me at Mary Anning's Revenge. You can search Amy Atwater too. You can call me Mary. I don't care. Everybody does. That's the best place. I've told myself I'm building a website, but I haven't. So just find me on social media.
All right. Well, thank you all so much for joining us today. As always, if you like this program and want to support programs like it at both the Alf Museum and the Western Science Center, you can find links on how to do that in the description below. Join us in 2 weeks when we have Hank Woolley from USC and the Natural History Museum of LA talking about Antarctic dinosaurs. So we're going from cool, nice Southern California to the very cold Arctic. And as always,
episode.
Yeah, right? It's going to be great. And as always, make sure you like and subscribe for more stories from the world of paleontology. We'll see you all in 2 weeks. Bye.